New multi-viewer magic from Ensemble Designs. Stunning detail and simple setup. Easy, click-to-fill configuration from your Mac, PC, or iPad. The new Avenue Multi-Viewer from Ensemble Designs.
So I'm going to talk to you for the next 9 minutes and 50 seconds about enterprise workflow and how to be efficient and profitable. So, what is an enterprise workflow? What is enterprise? Well, enterprise typically means something big. It means you've got a big facility, you want to do something big, you want to do it in volume, you want to do it in scale, and you probably want to change the way that your organization works because you want to do something big. And you've got some radical idea to make the thing big, but you've got to start somewhere. So what we're going to talk about is how do you take a small idea and a small test and turn it into a big and successful idea and make it work. So let's look at the life cycle of how an idea might germinate. You get the idea. You know you're going to do something that's going to radically change the way your organization handles media. You might be moving from file-based to tape-based. No, that's not right. Why would you do that? You'd move from tape-based to file-based. You might be going from a proprietary file-based system to an open standard file-based system. Whatever it is that you're trying to do, the first thing you need to do with your big idea is to communicate it. You need to find ways to write down how your idea is going to affect your organization. And you need to communicate that idea to a number of stakeholders in your organization. Normally somebody who has to sign off on the technology and somebody who has to give you some money. Because that's the next big phase of turning your small idea into a big idea, is to beg for the money. You get down on your knees and you ask the CEO, please invest these millions of dollars in my big idea because it's going to change the way that our organization works. And assuming that you have the charm, charisma and idea to pull that one off, the next thing you do is you normally end up having to build a proof of concept. And the proof of concept is intended to show the person who's giving you the money that you know what you're talking about and that the big idea is really going to work. And most proof of concepts I've seen tend to revolve around doing the idea on a single server. You try and put all the functionality together on one PC to save costs for the proof of concept. You put all your input media, whether it's tape or whether it's files, whatever it is, and you try to make all of the output media so that you're proving that your end-to-end workflow, whatever it is going to work. And that's normally the first thing you do in a proof of concept. You're more interested in the functional proving that it's going to work. That's the big thing. So that's good. You do your proof of concept, you prove it's going to work, and then you go back to the CEO and say, please can I have the rest of that money that you promised me so that I can build my big system? And with any luck, your proof of concept was sufficiently compelling that they give you all of that money, and then you move on to build your big system. So the example we're going to use here is a transcode workflow because it highlights a lot of the issues very well. So you've now got your money, you've built your big system. The next thing to do is to show that the proof of concept was valid. So you take all the same inputs that you had in the proof of concept and you make all the outputs and you show that the money was well spent because all the inputs go to all the outputs just like you said they would on the proof of concept. So you're now at the stage, you've got your big system and you're feeling very, very happy and you now set the thing into operation. And then there's a whole bunch of things that take place that you wish you'd known about when you did your proof of concept. A whole bunch of things that you wish you'd asked and explored during the proof of concept. These are issues to do with bandwidth, with network issues, things to do with contention between devices that are highly loaded, all trying to do the same thing at the same time. Issues to do with what happens when you're trying to operate on a file that's growing. What happens when the IT guy doesn't agree with your idea of what the access control and permission should be for the various devices and files? How do you cope with latency when you really want things to happen instantaneously but you can't engineer that? How do you fail over if one of your servers goes down? How do you ensure you still have enough capacity for your system to actually work? And once the system's been running for a while, you suddenly start to notice you're getting thousands and thousands of different transcode profiles in your system, and how do you manage those? And how do you design to have a stable and reliable system that you can update over time and continue to make money out of it? Well, all of those issues are really things that you can't solve, but you can mitigate against them, and you can put in place procedures, and you can design to minimize the effects and minimize the risk. So let's start with networks, bandwidth, contention, and access. How do you mitigate against those risks? How do you make certain that although you know they're going to take place, they're not going to impact upon your business? Well, one of the things to do is to really understand how your system works, to model your system so that you can start to troubleshoot when things go wrong. For example, one of our customers, they had a problem where everything worked on day one, but over time they realized that the real-time parts of their system stopped working at 2 o'clock in the afternoon. Now, I don't remember telling my engineers to put in the code, if it's 2 o'clock in the afternoon, then become unreliable. I'm fairly certain they didn't put that in the code. And what was actually happening was at 2 o'clock in the afternoon, people were leaving the office and backing up all of their projects, which increased the amount of loading on the storage, and the storage was suddenly not able to provide the bandwidth for the real-time operations. So because they didn't have a really good model for what was going on, and that's a daily operational model, they weren't able to predict that that was going to be an issue. So good modeling is important, and understanding how you can reconfigure your system to cope with those kinds of issues is something you have to do at the design stage and not fix up at the final last second. And that involves making certain that your design, your system, is able to change. So what about growing files and latency? We do a lot of work with our customer base to show that growing file workflows improve your efficiency. You get more throughput, more efficiency, more profitability if you can work on files that are growing in the latter stages of your workflow. And that's great until suddenly things start to go wrong. What happens if you're working on, say, an Aspera file transfer that's coming in, you're working on the growing file, and then suddenly the bandwidth disappears, and instead of the file transfer going 10 times faster than real time, is now going at 1/100th of real time. If you're working on a growing file, that means that you've committed a whole bunch of these resources to operating on that growing file. And now if it's going very slowly, those resources are now tied up working on something that's now very slow and not efficient for your operation. And again, this comes back down to good modeling, to understanding that these things can happen operationally, even though you don't want them to happen. There are external influences on your system that you cannot predict. So if you can understand how all the downstream operations relate to the upstream operations, you stand a very good chance of being able to change your system to make it work. And one thing we always try to help our customers with is to help them understand the difference between raw throughput and latency. In other words, latency is the amount of time between starting and finishing a job. And it's very difficult to optimize for both throughput and latency at the same time. And the final thing that I was going to talk about is profile explosion. If you end up with one profile in your transcode farm for every customer, for every deliverable, you end up with an enormous number of profiles. And as they change over time, and as those profiles have to cope with modifications to the delivery specs, rapidly you end up with profile explosion. Now, I'm going to make a quick analogy to the car industry. Back in the 1970s, you used to push cars through a manufacturing plant. And you'd make 1,000 red cars, and 1,000 blue cars, and 1,000 white cars. And then at the end of the month, you'd look at the parking lot and you'd say, oh look, I've got lots of red cars left over and lots of blue cars left over, but I've got fewer white cars. Oh no, next month I'll make more white cars and less red and blue cars. And that's incredibly inefficient because it means that you're making things that aren't going to be sold or aren't going to be needed. And it's the same in a transcode farm. If you can arrange your farm so that you're pulling deliverables through the farm in the same way that a modern car plant manufactures to order, they pull the car manufacturing process rather than pushing it. If you can arrange that this profile here actually takes a standardized profile and modifies it slightly for that deliverable, instead of having thousands of profiles, you end up with hundreds or even tens of profiles, and that's a much more manageable situation. But the final word is that although a system like a big transcode farm might be the thing that makes you all your money, it might be incredibly flexible and complicated. It is just one small part of the overall end-to-end facility workflow. And to really get the best out of your whole facility, you have to model and understand how upstream effects will change the behavior and dependencies of the downstream effects. And if you understand that, you'll be highly profitable and highly efficient. So thank you for listening. My name's Bruce Devlin. Don't forget to fill in your little cards where Kevin has got the box and will come and grab your cards from you. And don't forget to sign up to the AmberFin blog at blog.amberfin.com. We'll be providing more education materials to help you understand workflow, help you understand file formats, and help you understand how to be profitable. Thank you very much.